unclear to you, then make sure that you unmic and ask, okay? All right, here we go. Okay, so I'll give you another minute or so on the bell ringer. Some people just came in. Did Jackson ever make it in? Jackson never made it. How about Aiden? Did he ever make it in?
Aiden just joined.
Okay. But still no Jackson?
I mean, not Aiden, Jackson. My bad.
I just joined.
Okay, so Aiden's not with us. All right. Okay, go ahead and do the bell ringer, and I'm going to give you about another minute, minute and a half, and then we can talk about it.
Mr. Corbin, Jackson or Aiden or whoever's not in here, they might not be able to make it because just a minute ago when I was trying to join Go Guardian, it was popping up. Like it wasn't on the screen.
Yeah, anytime you guys join one of our meets, go in through Google Classroom and just click on the link that shows up there, and should be able to get in okay. Give me a second. Go ahead and write down the problem. I'm going to go back and see if one of those guys are having problems, okay? It's going to change your screen for a second. All right, looks like Aiden's in. Aiden, are you there?
Yeah, I'm in.
Okay, good deal. Can somebody text Jackson? Anybody got his number? I'm not sure if he's having trouble getting in.
I'm in.
Jackson's in?
Yeah.
Huh, I'm showing that you're offline.
I'm on my phone.
Oh, that's why. I got you. Well, good deal, man. Good to see everybody. Glad you guys could make it. I'd much rather do this than not have anything at all. So if you missed what I was saying earlier, today is going to be all about multi-step equations, reviewing the variables on both sides. And then I've got 2 or 3 problems that are some of those special ones that you're going to see. And they're not hard, but you're going to have to just be familiar with them and know what's happening when you see it, okay? Every class period, you guys come on. We'll be on for about 25 minutes. And then the last 5 minutes live, anybody that needs extra help can stay on. But after about 25, 30 minutes, we're going to cut this off, okay? So ask if you don't know. Keep your mic muted until you want to say something. But by all means, make sure you guys chime in when we start discussing this, okay? Anybody still working on the bell ringer?
I am.
Okay. I'll give you another 2. Okay, so remember with these multi-step equations, we've got these things called pre-shifts, right? And these pre-shifts are before we do see what's been done, undo what's been done, do it to both sides. You know, those 3 steps are going to be to any equation that you ever do from now on. But these pre-shifts, they're just kind of extra layers that are piled on top of that. And you just have to recognize that those have to be done first. What is the first pre-shift you see, or what's the first thing you think we need to do with this bell ringer?
Distributive property.
Yeah, and that's always going to be the case. 99 times out of 100, when you see distributive property in there, that's got to be something that you take care of, okay? And so with us right here, I mean, you see, this is your distributive property, okay? Can everybody see my hand and pen moving? It's not frozen, is it?
Yeah,
I
we
can
can
see
see
it.
you.
Okay, good deal. So again, when we say we distribute, what we're doing is the numbers against parentheses, and we're actually multiplying by everything in the parentheses. You got to be careful with your signs. Remember, minuses are negatives. So this is going to be a negative 6 times x. Gives me negative 6x. This is going to be negative 6 times negative 2, which gives me positive 12. Okay? And then what happens on this side over here? Anything happening on that right side?
You drop
Not
down the
yet.
other side.
Yeah, you just gotta put it down.
Right. You just drop it down. It's just hanging out, right? There's nothing really going on with this side yet. So, and that's what's going to help you, some of you guys, with these equations. Draw that line down the middle, do one step, bring the rest of the stuff down. Do one step, bring the rest of the stuff down. Okay? That's going to help some of you a great deal. Don't try to do 2 or 3 things in one step. Okay? Do one thing, bring it down. Okay, distributed property's gone. We've got that unlocked now. Okay, we can move on to the next level. So what do you see? What's the next pre-shift?
There's no more. You gotta start putting them together. Well, like terms, yeah, like terms.
Okay, well, now remember, those x's and those constants are like terms, but they're not on the same side of the equation, are they? So we can't just put them together. We have to make sure that now that they're on opposite sides of the equation, we've got to actually play the game to get them where they're supposed to be, right? So we call this variables on both sides, and we always want to get those variables to the same side, okay? That's one of our pre-shifts, variables on both sides. That's the one we learned yesterday. And which one is typically best to move?
-6.
We always want to try to take the smallest to the largest. Now, honestly, it works both ways, but when you take the smallest to the largest, it actually keeps you from having a negative coefficient. And so we're going to do the opposite here. We're going to add 6 to this side. And if we do it to one side, well, guess what? We've got to do it to the other side, okay? And so 6x, I'm sorry. And so these are additive inverses, and they cancel out. And I'm going to bring down my 12. And then negative 2 and positive 6 gives me positive 4. And then we bring down the negative 16. Now we've pulled the teeth, right? It's just a baby equation now. See what's been done, undo what's been done, do it to both sides. No more pre-shifts. So I'm going to add 16. If I do it to this side, I do it to that side. 28. These are additive inverses. 4x. Divide through by 4. And we get x equals 7. Okay? Now questions on that? Again, the main thing is don't get overwhelmed when you first look at an equation, okay? Look at it and say, all right, Mr. Corbin, he told me one step at a time. So I'm looking, I'm scanning, is there distributed property? Okay, yeah, let me unlock that. Bring everything down. Look for variables on both sides. Is there anything like terms I can put together? If they're on the same side, great, put them together. If they're on opposite sides, play the game, get them together. And then once you're out of pre-shifts, see what's been done, undo what's been done, do it to both sides. That's the way every one of these are going to pattern out. You're going to be able to, eventually, equations are going to be almost boring to you because it's going to be the same thing over and over and over again. Okay? Any questions on this problem? Okay. Everybody try this one. Once you start finishing up, go ahead and start talking about what maybe the first thing you guys would look to do. Hey, that line's more crooked than yours was yesterday. I can't have a line as crooked as yours. See if I can do better. Well, it ain't much better, is it?
Do you want us to start
Yes,
talking?
sir. Yes, ma'am.
Okay, well, first you have distributive property, so you need to do that first.
Okay, why don't I do this 3 plus 3 right here?
Because parentheses always come first because they're locked in.
Yeah, you've got to remember, and this is why I put this problem up here. That 3 is locked in with this distributive property, okay? It's tempting. You look at that and you go, oh, well, I can put 3 plus 3. I'd simplify that quick. Let's make it 6. But that 3 right there is locked in with this. So the 3 just kind of comes down here and hangs out, right? Okay. And then what on distributive property? Somebody tell me about the distributive property.
Multiply the 3 with everything inside.
Right. So that's going to give you 9x and then plus 15. And what do we do with this stuff over here?
Bring it down.
Right. Yates, is that you? Who is that talking to me? Who is it?
Caitlin.
Oh, it's Caitlin. Okay. I can't tell who you guys are when my machine's in screen mode like this. So you guys forgive me if I don't call you by the right name. Okay, now what?
Like terms.
I love that part of it. You got a like term that's already on this side, right? And so why not go ahead and simplify that just right off the bat? So 9x plus 18. And again, these cats are just hanging out, aren't they? Nothing to do with them yet. Okay? You can even mark them out if you want. All right, now what?
You gotta start putting them together or playing the game, however you want to say it.
Yeah, we've got variables on both sides here, don't we? So which one you want to move?
-4.
Right. So to get rid of a -4, I'm going to add 4x. If I do it to one side, I'm going to do it to the other side. Additive inverses. So this cat just comes down. 18 just comes down. And now I've got 13x, right? Okay. Any more pre-shifts? No more pre-shifts. So all I'm going to do is just see what's been done, undo what's been done, do it to both sides. So subtract 18. These are gone, additive inverses. 13x equals negative, what, 52? And then divide through by 13. And I think x is equal to what? 7? No, not 7. How many times does it go into 52?
4.
Thank you. And it's a negative.
Negative.
All right. So let's recap. Look at the pre-shifts. I've got a distributive property. That's always very first thing. This is first time you've had all of these together. So I've got some like terms that are already here. Might as well put those together. Let's be a family. Variables on both sides. Learned that yesterday. Let's get them together. Smallest to the largest. And then now we're down to just see what's been done, undo what's been done, do it to both sides. Okay. Got two more that I want to show you. This is going to be a little different. I'm anxious to see how you guys do on this one. So try that. Tell you what, time is really getting short on us. Why don't we do this? You guys, let's just talk and you walk me through this one. Get some people in there. You guys write on it as we go. Go ahead and get ahead of me if you need to, but tell me what do I need to do first?
The
Distributive property.
Okay, so this stuff's going to hang out right here. And then I'm doing this distributive here, and I'm doing distributive there. So -8, and then minus times a positive gives me negative 8x. Okay, now what?
Like terms.
Well, yeah, they're on opposite sides, but they're variables on both sides, right? They are going to be like terms. We just got to get them together. We can't just put them together. So how do I get rid of a negative 8x? I add 8x. I do it to this side, then I have to.
Do it to the other.
Right. So those cancel out. Leaves me with -14. Down to -8. What happens here? Are these added?
It would cancel out.
It also cancels out.
Yeah, they're additive inverses. So what's up with that? So look what just happened. What disappeared?
The variable.
Yeah, the variables canceled out. And so I'm left with negative 14 equals negative 8. Well, is that true? Will negative 14 ever equal negative 8?
No.
No. All right. So this is a special type of problem. You guys need to write this down in your notes and be prepared for it. When variables cancel out, there's two things that are happening. One of two things. When variables cancel out, one of two things is happening. Either you're going to have something that is never true, like these guys, negative 14 will never equal negative 8, or you will have something that's always true, like you might have 5 equals 5, or 10 equals 10, or negative 2 equals negative 2. And so this is what that tells you about the solution to the equation. If you get something that is never true, after the variables cancel out, there is no solution. In other words, there's nothing you can put in for x that's going to satisfy that equation. Okay? So you have an equation, you solve it, variables cancel out, you go, uh-oh, I've got one of two things happening. If this is true, then you're going to have what we're going to do here in a second. But if it's not true, it's no solution. Okay? If it is true, we say that it's infinitely many solutions or all real numbers. And I'll show you one like that here in just a second. Multi-step equation, variables cancel out. Something that's never true, no solution. Okay? All right, let's try another one. I can get a hold of it. All right, everybody try that one. As soon as you see it, you guys start talking about it. Because some people aren't going to see it.
Isn't it the same thing as last problem?
Okay, is it the same thing or is something different?
It's a little different.
Okay, so tell me how.
You get through numbers. It's true.
Okay, so let's just start. What's the first thing I do?
Distributive property.
Right. So these guys just kind of hang out, right? And so I'm going to distribute here to here. So that's a negative 8y. Here to here, that gives me positive 8. Okay, then what? Now, some of you might start recognizing that this side looks like this side, right? Now they're switched around a little bit, but the signs, negative 8y, negative 8y, positive 8, positive 8, you're going to,
They're both positive 8.
yeah, if you see those, then you're automatically going to know something's up. So what's the next thing you want to try to do? Let's say you don't recognize it. What's the next thing you do?
You add 8 to both sides.
All right, we've got to add this 8y because we've got variables on both sides, don't we? We do it to one side, we got to do it to the other.
They cancel out.
And then look, these cancel out, and now I get that. So what is that? Is that something that's true?
Yeah.
Okay. Need to write this
Yeah.
down in your notes. This is called an identity. An identity means that the solution is all real numbers. Or sometimes they say infinitely many solutions. Because what you can do is you can actually plug in anything for y, and it would make this equation true. Okay, so let me hit this for you again. We have some equations where the variables are going to cancel each other out. Okay, it's just going to happen. Don't freak out when it happens. Okay, when variables cancel out, this is what you're looking for. Is there something true happening, like 8 equals 8? Or is it like the last problem where you get like negative whatever 5 equals negative 6 or whatever it was? It was just they weren't true, right? If you get something that's true, your solution is all real numbers. In other words, it's infinitely many solutions. You can plug in anything and it satisfies the equation. That's called an identity. If you get something that's not true after the variables cancel out, that means there's no solution. In other words, there's not any number you can plug in that makes the equation true or satisfies it. Okay? So variables cancel out, one of two things. If I get something that's true, my solution is all real numbers, infinitely many solutions. If I get something that's never true, then we have no solution. Okay? All right, guys. What questions can I answer for you? All right, what you guys want to do is I'm going to post up I'll probably get it on there today. I'll post up the assignment for tomorrow. It could be a quiz, it could be IXL, it may be just a Edpuzzle video with a few questions, but whatever it is, it's going to count, okay, on the new 9 weeks. So if ever you have any questions, talk to each other, post it on Google Classroom. I usually check it a couple times a day, and I can help you out just whenever you need it, okay? Anybody have any questions? Okay, you guys know I love you. And if you have any questions, you want to stay on, you can stay on. If not, you guys can go ahead and log out, and I'll answer anything else you need here in the next 5 minutes, okay? All right, see you guys.
See ya. I do have one question. Do you like cheese?
Do I like what?
Cheese.
Cheese? Who is this,
Yeah.
Mr.
Yes.
I would ask that question. Look, does a one-legged duck swim in a circle?
I don't know how to answer that.
That answers your question with a question. Yeah, well, yeah. What kind of person doesn't like cheese?
I know, right? Unless you're lactose intolerant.
That would be trouble for me because
That's the only excuse.
I love cheese, man. I love grilled cheese. I love cheese on my salad. I love cheese on my sandwiches. I love cheeseburgers. I love macaroni and cheese. What's not to love about cheese?
Everything except for macaroni and cheese.
What?
Macaroni cheese.
I know, right?
What kind of man are you, Spencer?
I'm a man with good taste. Everyone else has really bad taste.
I think it's just because you've never had Miss Lori's macaroni and cheese. She makes it from scratch, man. It's good stuff. It's like a family
I like
recipe.
cheese by itself.
I do too.
I mean, I remember there's. I think it might just be my taste buds as well, but because I remember one time me actually liking it somehow.
Some people don't like the noodles. They can't handle the texture of the noodles, and so that gets them. I don't think it's anything against cheese. It's just the noodles.
Yeah, it's not the cheese; it's the noodles. I'm very picky about noodles.
All
Like
right, guys.
spaghetti noodles are like the only noodles I'll actually eat.
Right.
Yeah.
So you're not a big tortellini fan or linguine or anything like that?
No, I'm a simple man. I'm a simple man.
Simple man. I don't know how much more simple you get than macaroni and cheese.
No, I've heard that like you can add a bunch of stuff to it.
Yeah,
I
now
don't remember where, but I just heard that.
I'm not for that. A lot of people like put ham and stuff like that. I'm
Yeah.
not. I want my macaroni and cheese, just macaroni and cheese.
Well, I don't like mac and cheese at all, so that's the way I like it.
Right. So, Jace, you or Spencer have any questions? Anything I can answer for you other than my taste in macaroni
Deer
and cheese?
season going through Christmas.
Is what?
Deer season going through Christmas.
Well, there's different seasons that come in and go out. The modern day rifle season comes in Saturday, and it stays in for 3
Yeah.
weekends. So that's 2 weeks
Mhm.
plus 3 weekends. But then you have a second muzzleloader season that comes in December, and of course bow season never goes
Mhm.
out. Bow season stays in through the end of the year. That's crossbow or longbow.
Okay.
One. So,
Thank you.
all right. If you kill a big deer, you need to email me. Show me a picture.
Okay.
All right.
Have a
You
great
guys-
rest of your day.
Bye.
All right, guys. Talk to y'all later.
See ya. Bye.
You too.